See, in the last class, last topic, regular expressions. Next, first we discussed handling dynamic objects. Next, error handling. We already discussed next search operations. First, handling dynamic objects. We already discussed. Next, search operations. Search operations also we discussed in file system object model. See once again. See. Using regular expression object. Just a minute. Aarti, can you hear me? See, UFT is a functional and regression test tool. UFT is an object-based test tool. Next, UFT is UFT say my requirement is find how many times the word UFT appeared in a text file. See. Count how many times the word UFT appeared in a text file. See in this script combination of file system object and a regular expression object. See regular expression object is unmatured object using a no specific class value for creating regular expression object. Then how to create regular expression object, Sujata? How to create regular expression object?
New and regexp are the keywords we can create regular expression.
Yes, regular expression object. Using new and regexp, not case sensitive, keywords, we can create a regular expression object. See set ob variable, set variable equal to new regexp. Say dem objfso. See first we need to read the data. For reading text stream object required obj text stream obj regex matches. See, set obj regex obj fso equal to create object of class value scripting dot file system object. Scripting dot file system object. Next, create text stream object. Madhuri, how to create text stream object?
Set obj text stream equal to
Set obj
text stream
equal to
obj fso.
Good. Obj fso dot
open
file already there. Open text file of
and
file
path
path and comma file mode. File mode read. See, read is default mode. You don't need to specify. Okay. Next, create a regular expression object. Set obj regex equal to new regexp. Next, first read entire content into variable. Suppose one variable my content, or you can use file content. File content equal to obj text stream dot read all. Next, see, regular expression object model is unmatured model. A few methods and properties available in this object model and no context help. See, object dot pattern equal to uft. Next, object dot ignore case equal to true. Next, object dot global to find all matches. Otherwise, after finding first match, it stops searching. Next, store the object reference. Set matches equal to object dot execute of what we have to execute, Sujata, what we have to execute?
The text stream.
File content.
File content.
File content. Next, you can display matches dot count. Next, internal closing of the file, object dot close. Next, release the memory for all three objects, obj regex equal to nothing. Next, set obj text stream equal to nothing. Next, obj fso equal to nothing. Run the script. Seven. Next, suppose ignore case. Comment this statement, then it will find only uppercase. 4. Next, global. Comment the statement. Then what is the output, Madhuri?
It shows all the UFT, sir.
Suppose if I comment the statement global equal to true, then what is the output? Sujata.
It will take UFT lowest case, sir.
Pardon?
No. No, sir.
After, if you don't use this statement, what will happen? After finding first match, it stops searching.
It stops.
Means output 1. Suppose if we use the statement object dot global equal to true, then it finds all matches. See, 1. Suppose global equal to true, it finds all matches. Any confusion, Madhuri?
Sir, no confusion.
Okay. See, same example. Count how many times the word you have typed in a Word document. Word document. Just a minute. First, create a Word document. Create a Word document. See, you know how to create Word application object. See, dem obj word. Next, set obj word equal to create object of class value o dot application. Next, object dot visible equal to true. This is optional statement. If you want to view the operation during execution, use this statement. Next, object dot documents. Say if it is Excel object model, workbooks dot add. Here documents dot add. Next, object dot active document. Active the document means select the document. dot save as, new file na save as, provide the path. Suppose I want to store on desktop. xyz dot doc. Next, obj word dot quit. See, close the word application. Next, release the memory. Set obj word equal to nothing. Observe. Created na xyz. Just a minute. Next, this one. Count how many times the word UFT appeared in a Word document. Uncomment. Say obj word. See, our test automation point of view, word object model is limited use or no use. Most of the time we use file system object model, Excel object model. Remaining object models rare use. Database object models okay, but word object model rare use. See, obj doc. Here you can create sub object document object. Obj word dot application. Next, obj doc document object equal to obj word dot documents dot file already there, open method. xyz dot doc. See, file content is sometimes it won't provide a context help for word object model. Sometimes you can get. See, obj doc dot content property. Obj word equal to nothing. Quit the word application. See, word dot application. Seven. Next, ignore case. Comment this statement. 4 only. Next, global. Comment global statement. After finding first match, stop searching. See next important chapter, object identification. Object identification configuration. Object identification configuration. Say, first of all, this feature is related to, this configuration is related to object repository based test design only. See, we have two types of test design. One is object repository based test design. Another is without repository, descriptive programming. This object identification configuration is related to object repository based test design only. If we use descriptive programming for creating tests, you no need to touch this feature. Say, this configuration, this object identification configuration is related to object repository based test design only. Got this point, Sujata? We have two types of test design now in UFT.
Yes, sir.
This feature is related to object repository based test design. Suppose if we use descriptive programming for test design, you no need to touch this feature. Okay, see, up to now we created and executed so many tests using object repository based test design. See, recording is object repository based test design. Keyword driven methodology also object repository based test design. If it is local repository or shared repository, comes under object repository only. We created and executed so many tests, but we didn't touch this feature. Why? Say, UFT has default configuration for every environment. Here environment means add-in. For example, for ActiveX environment, one configuration. For Visual Basic environment, another configuration. For web environment, one configuration, like that. Say, Win button object in Windows environment configuration is different from web button configuration. Web button in web environment. Say, configuration, object identification configuration varies from one environment to another. See, next point, UFT has default configurations for default configuration for every environment. Here environment is a add-in. Example, a ActiveX, Visual Basic, Web, etc. Next, object identification configuration varies. Object identification configuration varies from one environment to another. Next, first of all, what is object identification configuration? See, what is object identification configuration? Configuring objects using important properties in order to recognize them uniquely. Configuring objects using some important properties. Configuring objects using some important properties in order to recognize them uniquely. What are the important properties? See, this UFT default configuration based on industry standards, UI design standards. Suppose button in Windows environment. Every button should have label, name, text property. See, UFT default configuration based on industry standards, UI design, user interface design standards. You no need to learn those standards. UFT default configuration based on UI design standards. Say, if we follow, if our developers follow UI design standards for UI design, then we no need to touch this feature. Why? UFT default configuration based on UI design standards only. Then when we need to configure some more, see, you no need to configure from scratch. Default configuration available for every environment. Whenever the default configuration is not sufficient for our application, then we can configure some more, not from scratch. Just a minute. What is object identification configuration? Next, first of all, why object identification configuration? Suppose you take one object using all properties information, you can identify the object now. Then why we need to configure? See, two reasons. First reason, every object having 20 to 30 properties, approximate 20 to 30 properties information. For every object, we have 20 to 30 properties information. Using that complete information, recognizing objects is time-taking process. See, performance issue. That is one reason. Another reason, important reason, some properties may have dynamic, some properties values may change dynamically throughout the execution. That time, UFT may not execute scripts properly. Suppose if you execute any script second time, if any dynamic property value is there, it may not execute. See, two reasons. Why object identification configuration? See, for every object 20 to 30 properties information available. See, you take general example also. Suppose man is object. Generally we identify man object using name property. Suppose name is duplicate. Suppose two persons having same names in our circle. That time we use one more property, surname or any other property. See, suppose man is object. Properties, name is one property, surname, age, color, height, etc. See, for every software object, we have 20 to 30 properties information available. Using that complete information, recognizing objects is time-taking process. This is one reason. Second reason, some objects, not all objects, some objects may have some objects property values, property value, some objects property values may change dynamically throughout the execution. Suppose if any object property value changing dynamically, then script may not execute second time script may not execute properly. If you want to execute any script multiple times, it won't execute. See, first reason, every object we have 20 to 30 properties information. Using that complete information is using that complete information, recognizing objects is time taking process. And one more reason, just a minute. See, using that complete information, recognizing objects is time-taking process. Second one, some objects may have some object property values may change dynamically throughout the execution. Two reasons. See, in order to solve these two problems, UFT follows. UFT uses some important properties information to recognize objects. See, this is about why object identification configuration. Tell me, Kanti, first, what is object identification configuration? What is object identification configuration?
Configuring important properties information for object recognition is for object recognize them uniquely.
Say, configuring important properties information for objects to recognize them uniquely. Okay. Next, Madhuri. First of all, why object identification configuration? You can use all properties information na. Why configuring objects? Use all properties information.
Yes, because every automation objects will be having
Not automation
20
object.
to 30
Just a minute. Automation object term is different. Here test object.
test object. Yes, the test object will be having 20 to 30 properties. So, so memory usage will be more. So,
Using that complete information, recognizing objects is time taking. That is one reason. Another reason, important reason. Continue, Sujata.
Some objects' property values may change dynamically throughout the execution. In order to solve these problems, UFT uses some important properties information to visualize objects.
See, observe. I have explained two reasons. See, suppose this is a dialog box, tools menu, objects pie. Show the dialog box. Observe properties and values. Properties. See, so many properties. 20 to 30 properties information. Next, show this OK button. Observe so many properties. Next, using this complete information, recognizing objects is time taking process. That is one reason. Next, second reason, some object property values may change dynamically throughout the execution. Suppose if we use all properties information, what will happen? Suppose in next iteration, one property value is changing. That time, UFT won't recognize that object. Confusion. UFT will show error. See, show this flight reservation window. Here, properties information. Suppose one of the property information is window ID. Window ID. Observe, what is the window ID? Window ID. Just a minute. See, remaining properties may be same. Suppose visible true, text property flight reservation. Next, relaunch the window. Relaunch the window. Show the window. Text property same. Flight reservation. Next, window ID. This time another value. Observe, Kanti, both are same or different. Window ID property values. Earlier it was 33 something, this time 50 something na. If we use this property, all properties information, what will happen? Suppose if you execute the script second time, it won't execute na, error na. Okay na, Sujata, understand this concept?
Yes, sir.
Okay. See. See, what is object identification configuration? Why object identification configuration? Next, when just a minute. When object identification configuration is required. When it is required. See, I will explain some scenarios. Concentrate. See, if we use scenario 1. If we use descriptive programming for test design. Observe, Madhuri, in this scenario, object identification configuration is required or not?
No, sir, it is not required.
For descriptive programming, not required. Next, if we use object repository based test design and developers followed UI design standards. Observe, Sujata, in this scenario, you have object repository based test design, but developers followed UI design standards. Here, object identification not required. Next, third scenario, just a minute. Third scenario. Say if we use object repository based test design and developers should not followed UI design standards. Observe small enhancement in second one. If we use object repository based test design and developers followed UI design standards, not required. Why? Default configuration is sufficient for recognizing objects. See, in this scenario, UFT default UFT has default configuration for every environment. UFT default configuration is sufficient Why? UFT default configuration based on industry standards, UI design standards. User no need to configure. Default configuration is enough. Next, if we use object repository based test design and developers not followed UI design standards. Madhuri, developers not followed UI design standards.
It is required, sir.
See, required. Okay. See, final conclusion. Tell me, Sujata, when object identification configuration is required? When it is required?
When object repository based test design and developers did not follow the UI design standards, then it is required.
Okay. See, whenever we use object repository based test design and developers not followed UI design standards, then configuration, object identification configuration is required. Say, I think all of you familiar with these three concepts. What is object identification configuration? Why object identification configuration? Next, when object identification configuration is required. Next, we already discussed UFT has default configuration for every environment. This is environment level, means web is one environment. Environment means here add in ActiveX one environment, standard Windows one environment, etc. See, UFT object, just a minute. UFT object identification configuration is environment level. Here environment means add in. Example, standard Windows. Next, first environment level. Next, test object class level. Test object class level. Example, standard windows. Win button or win edit or window. Win button or win edit or window. Suppose web, environment web, web button, link, page, browser, etc. Say first environment level, then test object class level. Suppose standard Windows is the environment. In that environment you can find 18 to 20 classes of object. See standard Windows. See these are the test object classes. Dialog, win button, win checkbox, win combo box, win edit, etc. Suppose web is environment. These are the test object classes. Browser, image, page, web button, web edit, etc. See, if you configure button object in Windows environment, then that configuration is applicable for all buttons in our project. Example, in our Windows application, we have 20 screens, 400 buttons or 200 buttons. In our Windows application, we have 20 windows and 200 buttons. If you configure button class, that configuration is applicable for all buttons in our project. Suppose ours is web application. If we configure link object in web environment, that configuration is applicable for all link objects in our web application. Suppose in our web application 20 pages are there, 200 links are there, or 300 links are there. If you configure link object, that configuration applied for all 300 links in our web application. Got this point, Kanti? Any confusion?
Sir, understood.
Okay. First environment level, next test object class level. First take environment, then take objects one by one and configure if required. Next, here object identification configuration, 3 types. First one, object identification configuration. See, first one, normal identification. Normal identification. Say in this normal identification, we use 2 types of properties. That is default. 2 types of properties. Mandatory properties. Next, assistive properties. Mandatory properties, assistive properties. Next example, button, win button. Win button. Button in standard Windows environment. Standard Windows environment. Suppose for button we used mandatory properties. Just a minute. Mandatory properties. Text native class. Next, assistive properties, height, width. Next, ordinal identifier. Ordinal identifier. Here for all objects, two types of ordinal identifier. One is index, another is location. Index based on programming sequence. Suppose developers first created login dialog box. Index starts from 0 to n-1. Developers first created index login dialog box. Then cancel button. Next agent name edit box. Next help button. Next password edit box. Last OK button. See, this is the programming sequence. See, index based on programming sequence. Location. Location, object present in the application. Object location, top left to bottom right. Here login, agent name, password, OK button, cancel button, help button last. Location based on object presence in the application. Index based on programming sequence. See, both are IDs 0 to n-1. See, 0, 1, 2, 3, like this. Location. Location also in IDs 0, 1, 2, 3, like this. Say, first, normal identification. What is the normal identification process? Say, during learning. Learning means recording is learning. While recording, UFT learns objects. Suppose if it is shared object repository method, add objects is learning. While adding objects, UFT learns. While adding, UFT learns objects. During learning, UFT first reads all mandatory properties at a time. See, during learning, UFT first reads all mandatory properties at a time and thinks whether that information is sufficient or not for recognizing that object uniquely. If it feels sufficient, it stops learning and stores that information. While execution, it uses that information. See, first step, normal identification process. During learning, what is learning, Madhuri? What is learning?
It is learning may be during recording or while adding the objects in the shared repository.
Recording is learning. Recording is learning. While recording, UFT learns objects. Next, add objects is learning. While adding objects, UFT learns. During learning, UFT first reads all mandatory properties at a time. All mandatory properties at a time, and thinks whether that information is sufficient or not. Sufficient or not to recognize the object uniquely. See, if it feels sufficient, then it stops learning and store that information. While execution, it uses that information. Otherwise, it goes to assistive properties, and learns properties one by one. See, mandatory properties all at a time, assistive properties one by one. Next, if it feels, see, and thinks, just a minute. Same. Then it stops learning and stores mandatory and assistive properties. Next, another scenario. Suppose after learning all mandatory properties and assistive properties, after learning all mandatory properties and assistive properties, still it feels that information is not sufficient, then it goes to ordinal identifier, ordinal identifier and learns index or location ID based on that selection. Any one that is a drop down box, either index or location. Suppose if index selected, it learns index ID, location selected, location ID. See, user can change the index or location and learns index or location ID. See, for all objects index or location, for browser object one more property, creation time, object loading time. We already used creation time in descriptive programming. Creation time also 0, 1, 2, 3 like that. It is only for web, only for browser object, only for browser object. For all objects index or location, two identifiers only, either index or location. For browser object, one more identifier, creation time, only for browser. See, this is about normal identification process. Tell me, Sujata, what is normal identification process?
Normal identification process during learning or recording or adding objects. UFT first reads all mandatory properties at a time and thinks whether the information is sufficient or not to recognize the objects uniquely. If it feels sufficient, then it stops learning and stores that information. Otherwise, it goes to assistive properties and learns properties one by one. After learning all mandatory properties,
if it feels sufficient, then it stops learning. Okay, stores mandatory and assistive properties. While execution, it uses that information. Suppose after learning, continue.
After learning all mandatory properties and assistive properties, it feels that information is not sufficient and then goes to ordinal identifier and learns index or location ID. Creation time in case of browser.
Browser only. Next, say ordinal identifier, either index or location or creation time is unique. Then you can ask one question. If ordinal identifier is unique, then why we need to follow all this configuration, mandatory properties, assistive properties, etc. We can directly use ordinal identifier now. Okay. Say ordinal identifier is unique, but no guarantee for next build. For this build, this software build, you can use index or location or creation time guarantee. But for next build, no guarantee. Why? See, developers frequently change the code. So they change the code. Index may vary for next build. And developers change the object's alignment also. So we cannot depend on location also. Say index or location may be unique for this build only, for next build no guarantee. So we cannot depend on ordinal identifier. This is rough identification. Final one. Okay, in order to sort out this problem, one more configuration is there. That is smart identification. Smart identification. See, smart identification means normal plus smart. Normal identification means only normal identification. Smart identification means normal plus smart. See, this smart identification is optional. If required, you can enable the smart identification. This is also test object class level. Suppose in our environment 20 classes of object available. Example, window, dialog box, win edit, win button, win checkbox, etc. For 18 classes of objects, normal identification is enough. For remaining 2 classes of objects only, you can configure smart identification. Got this point, Madhuri? Smart identification optional. Wherever required, you can enable the smart identification.
Yes,
Suppose in our environment 20 classes of object available, for 18 classes normal identification is sufficient. For remaining 2 classes only you can configure smart identification, isn't it?
Yes, sir.
And one more thing, even though you configure smart identification for any object class, it won't take smart identification properties for all objects, only required objects. Suppose, just a minute. Suppose we configured smart identification for button object. Suppose in our standard Windows environment, 20 classes of objects, for 18 classes of object or 19 classes of object, normal identification is enough. For button, normal identification not sufficient. In order to avoid this rough identification ordinal identifier, in order to avoid rough identification normal identifier, we configure smart identification for button object only. Even though we configure smart identification for button object, it won't take smart identification properties for all objects, only for required objects. Just a minute. In smart identification, we use 2 types of properties. Base filter properties. Base filter properties. Next, optional filter. Properties. Suppose base filter properties for button object. Example, window ID. Next, X coordinate. Next, optional filter. Suppose Y coordinate. Say 1 or more properties you can use. Suppose I configured smart identification for button object. In our application, total 200 buttons are there. For 120 buttons, recognized using mandatory properties only. Mandatory properties. Next, suppose 20 buttons recognized using mandatory plus assistive properties. See, for remaining 60 buttons only, it goes to smart identification. Suppose 40 buttons. Smart identification. Identification using base filter. Properties. Base filter properties. Next, see 180 recognized. Suppose 8 buttons. Smart identification, just a minute. Smart identification using base filter plus optional filter. Still 2 buttons are there. What will happen? Finally, it goes to ordinal identifier only. See, anyhow, ordinal identifier is dead end. Ordinal identifier. No other way. Smart identification. Suppose normal identification. Observe Sujata. Normal. Suppose total 200 buttons, 120 recognized using mandatory. Next 20 recognized using mandatory plus assistive. Next, remaining 60 buttons.
Normal.
How to
smart identification.
Here no smart identification, only normal identification.
The ordinal identifier.
Yes, ordinal identifier. In order to avoid this rough identification, you can configure smart identification. Here smart identification means normal. Smart identification means normal plus smart identification. Okay, na Kanti, did you understand this concept? Any confusion?
Yes, sir, I understood.
Okay, cool. Observe, Madhuri. In case of normal identification, the position of ordinal identifier is 3.
Third one.
First, mandatory properties, second, assistive properties, third one, ordinal identifier. Next, in case of smart identification, means normal identification plus smart identification. The position of ordinal identifier is 5th. Yes. First, mandatory properties, next assistive properties, next base filter properties, next optional filter properties, last ordinal identifier. Okay, na Sujata, this concept?
Yes, sir.
Next, say we discussed normal identification process. You can write a smart identification process also. You write, I will just explain this configuration. Smart, you can write later. Smart identification. Smart identification. Smart identification means normal identification plus smart identification. Okay. What is the smart identification process? Same, first normal identification. During learning, UFT first reads all mandatory properties at a time and thinks whether that information is sufficient or not to recognizing that object uniquely. If it feels sufficient, stops learning and stores that information. Otherwise, it goes to assistive properties. There it learns properties one by one. If it feels sufficient, it stores that information. Information means mandatory plus assistive properties. Otherwise, suppose after learning all mandatory properties and assistive properties, still it feels that information is not sufficient. Finally, it goes to ordinal identifier and learns either location ID or index ID based on that selection. Suppose user set ID, it reads ID. User sets index, it reads index ID. If user sets location or default also there, either index or location is default, but user can change the default setting, but any one ordinal identifier is mandatory. See, finally it goes to ordinal identifier and learns either index or location ID. Okay. Suppose after learning all mandatory, that is normal identification. Smart identification, first mandatory properties, next assistive properties. Suppose after learning all mandatory properties and assistive properties, still it feels that information is not sufficient, then it goes to base filter properties. There it learns all base filter properties at a time. Observe, in normal identification all mandatory properties at a time. In smart identification all base filter properties at a time, and thinks whether that information is sufficient or not for recognizing that object uniquely. If it feels sufficient, it stops learning and stores that information. Otherwise, it goes to optional filter properties. There it learns properties one by one. Suppose after learning all base filter properties and optional filter properties, still it feels that information is not sufficient. Finally, it goes to ordinal identifier. There it learns ID, either location or index. This is the smart identification process. Observe once again, in case of normal identification, first mandatory properties all at a time, then assistive properties one by one if required. Suppose mandatory and assistive not sufficient, finally it goes to ordinal identifier. In case of smart identification, first as usual all mandatory properties at a time. If not sufficient, assistive properties one by one. Suppose mandatory and assistive not sufficient, next base filter properties at a time, all at a time. Not sufficient, optional filter properties one by one. Suppose all mandatory, assistive, base filter and optional filter properties not sufficient, finally it goes to ordinal identifier. Okay now, Sujata, tell me, what is the smart identification process?
Smart identification process, first mandatory properties at a time. Then it will go to assistive properties and mandatory properties at a time. Next it will go to base filter.
Repeat once again.
First it will go to mandatory properties at a time, sir.
All mandatory properties at a time.
And then mandatory and assistive properties.
Forget about mandatory. Then assistive properties one by one. Assistive properties one by one. Suppose after reading first assistive property, if it feels sufficient, then it stores mandatory plus first assistive. Suppose not sufficient, second assistive, like that.
And then base filter properties at a time. If that is also not sufficient, then it will go to optional filter properties.
One by one.
Then if that is one by one, and if that is also not sufficient, then it will go to ordinal identifier.
Okay. Okay. See, in case of normal identification, first priority all mandatory properties at a time. Next, assistive properties one by one. Then it stores mandatory plus assistive. Next, last priority, ordinal identifier. Okay. See, in case of smart identification, same, first two. Next, all base filter properties at a time. Next, optional filter properties one by one. Next, finally, ordinal identifier. See, I will show the example. Concentrate. Okay, now understand the concept, Madhuri? Normal identification process, smart identification process.
Yes, sir.
Okay. Observe tools object identification. Suppose my environment is standard Windows button. See, in order to explain this concept, intentionally I am changing this one. Suppose this is the configuration index. This is the configuration for button object. Observe Kanti, what are the mandatory properties? Just a minute. Standard Windows Win button. This is the configuration for button class in Windows environment. What are the mandatory properties?
Native class text.
Assistive properties.
Native class text.
Assistive properties. Height width. Ordinal identifier.
Index.
Smart identification. Not enabled.
You have to configure.
Not enabled.
Not enabled.
Just position. I am asking the current situation. Not enabled, na?
Yes, sir.
If you check this one, enabled. You can configure base filter, optional filter, but not enabled. Say in this scenario, mandatory properties native class text, assistive properties height and width, put mute, ordinal identifier index, smart identification not configured. Okay. See, record the navigation. Click this new open order button. In this navigation, I operated first button. Open order button. Next, click OK button. Second button in the navigation. Next, update order. Just a minute. Update the tickets. Third button. Next, click new. Stop. See, in this navigation, I operated 4 buttons. Go to object repository. See. OK button. See, it stored only mandatory properties. OK button. Text property value OK. Native class property value button. No assistive properties and no ordinal identifier. Why? Madhuri, tell me why it stored only mandatory properties for this OK button?
Because first it takes the mandatory properties.
Sujata, why it stored only mandatory properties? no assistive properties, and no ordinal identifier for this OK button. Why? Kanti?
Because the native class and text are unique, sir.
Yes.
That's why we haven't.
Not native class or text. You can't say. Actually, native class is not unique. Mandatory property is unique. See this OK button. OK label is unique. No other button with same label. Mandatory properties are sufficient for recognizing this object. That's why it's stored only mandatory properties. No need to store assistive properties. No need to learn assistive properties and ordinal identifier. Next, take update order. It's stored only mandatory properties. No assistive properties. No ordinal identifier. Why? What is the reasons? Madhuri?
Because these properties are sufficient for recognizing the object.
Sufficient. Next, select this button. For this button, no label. No label. Observe. Top left to right. This button. No label. So no text property. Native class button. Button is not unique. In this window, nearly 10 buttons are there. Next, it stored assistive properties also. Height, width. But heights and widths are also not unique. In this window, 6 buttons having same heights and widths. Next, it stored ordinal identifier index. Next, button 2. Mandatory not sufficient. Assistive not sufficient. It stored index 4. Okay na? Sujata, understand this concept?
Yes, sir.
Next, in case of smart identification. Say. See, select environment, select test object class, suppose win button. Observe, suppose we are configuring smart identification for this win button in order to avoid rough identification, ordinal identifier. See, base filter properties enabled. Next, window ID, optional filter properties, X coordinate, Y coordinate. See, this is the configuration for this button object. Mandatory properties, native class text. Assistive properties, height and width. Next, smart identification enabled. Base filter properties enabled, window ID. Optional filter properties XY. Next, ordinal identifier index. Okay, take new test. See, record the navigation. Click new, click open order button. Next, OK button. Next, update order button. Next, new order button. See, in this navigation, I've operated 4 buttons. Run the script. Just a minute. Tickets same now. That's why it is showing. Okay, suppose this time 2 tickets. Run the script. executing. Next, open object repository. OK button. Observe Sujata, even though we configured smart identification, it stored only mandatory properties for OK button na?
Yes, sir.
No ordinal identifier. Next, update order, same. No assistive properties, no ordinal identifier. Next, this button. Stored mandatory, assistive, not sufficient. Next, smart identification, true. But ordinal identifier also it's stored. See, safe side. If smart identification not sufficient, then it uses. But in this scenario, it uses smart identification properties only. For next one, it stored ordinal identifier, mandatory plus assistive ordinal identifier, but it uses smart identification properties only. How can you say? See, we already ran the script. Launch result window. Observe this button. Observe Madhuri, what it is showing? The smart identification mechanism invoked na?
Yes, sir.
Raise an object not unique, 6 objects found. See, smart identification base filter properties, 1 object found. Window ID 5. Next, this button. Smart identification mechanism was invoked. See here, base filter properties, window ID 6.
Yes.
Okay, na? Here in
Yes,
this
sir.
scenario, it is using smart identification properties for those 2 buttons, na?
Yes, sir.
Okay. See next, some points observe. Suppose we already discussed, if you configure any test object class, that settings can be applied for all objects from that class. Suppose my scenario is I have 200 buttons. Out of 200 buttons, for 100 buttons, default configuration is not sufficient. Only for 100 buttons, default configuration. Then you can configure the object class. That configuration applied for all 200 buttons. Okay, another scenario. See, in my application, 200 buttons. For 199 buttons, default configuration is enough. See here, next, only 1 button. If you configure object identification, that setting can be applied for all 200 buttons. Here only 1 button varying, remaining 199 buttons, default is enough. But in first scenario, for 100 buttons default. For remaining 100 buttons, default not sufficient. See, default not sufficient. Then configure the class. This configuration is for all 200 buttons. Okay, na Sujata, understand this concept?
Yes, sir.
100 buttons. For 100 buttons, default configuration sufficient. For remaining 100 buttons not sufficient, then we configure. Then what will happen? Configuration that latest configuration for all 200 buttons na?
Yes, sir.
Next, another scenario, 200 buttons, same 200 buttons. For 119 buttons, default is sufficient, or 198 buttons, default is sufficient. For 1 or 2 buttons, default not sufficient. Then configure the object, not class, just configure the object. Next, this configuration only for that object. This configuration only for that object. For remaining 199 buttons,
it's not applicable.
Default configuration only, isn't it?
Yes.
Default only. Say, means final conclusion, you can configure test object class or just particular object based on your requirement. Say, we can configure test object class or particular object. See, in the second scenario, class level not required, only one object. Okay, how to create? Just a minute.
Sir?
Tell me.
Here configuring the objects is adding objects or what?
Configuring objects is?
Adding objects?
No. Adding objects, recording, that is learning process. Configuring means you need to configure. What is configuring? What is configuring? What I told? Configuring objects using some important properties in order to recognize them uniquely. That is configuring objects. Next, how UFT recognizes objects? When UFT recognizes objects? During learning, na?
Yes, sir.
What is learning? Recording is learning. Recording is learning, or add objects is learning. Don't confuse.
Yes, sir.
See, configuration is different. Add objects is different. Configuration is configuring important properties information. Add objects means while add objects, UFT learns objects, or while recording, UFT learns objects, isn't it?
Yes, sir.
See, just a minute. Observe. Suppose in our application, all buttons are recognizing uniquely using default configuration except this help button or except this cancel button. Just a minute. Object repository. Suppose this cancel button is not recognizing. In our entire application, this cancel button only not recognizing using default configuration. Remaining all are recognizing using default. For this cancel button, you can add some more properties. See cancel. See here, add description properties. Suppose this cancel button, I am adding one more one, window ID. Observe this window ID property only for this cancel button, not for remaining buttons. Okay na Kanti?
Yes, sir. Yes.
How to configure particular object? Open object repository, select the object and add property. See, next one more topic. We will have different configurations. We will have different configurations for same environment. Same environment. Try to understand this concept, Sujata. We will have different configuration for same environment. Suppose in our company, 3 projects running. See, 3 projects running simultaneously. We are using UFT tool for all 3 projects. 3 projects are web applications, three projects are web application, same environment, web environment. 3 projects are running using, see, 3 projects are running using UFT. All projects are web only. All are web only. Suppose for first application configuration is different. Default is not sufficient for all these 3. Example, default is not sufficient for all these 3. For first application configuration is different. Second application configuration is different. Third application configuration different. Then we have to maintain 3 different configurations for same environment now, isn't it?
Yes, sir.
We have to maintain 3 different configurations for same environment. How to maintain? Say, Observe. First, we can maintain three different configurations if required. If not required, you can use single configuration. Three different configurations for these projects. How? See, first configure first application, and generate script. This is predefined AOM script, VBS file. By executing this file, you can get this configuration. First, generate first application, configure first application and generate script. Configure, generate script and store. Next, come back to default configuration. Come back to default configuration. Next, second, configuration second application. Configure second application, generate script and store the script. Next, come back to default configuration. Next, third, configure third application, generate script and store. Next, whenever you want to execute tests on first application, see, whenever you want to create and execute tests on first application, then run first application script, configuration script, that is AOM file, predefined AOM file script. Next, whenever you want to automate third application, Madhuri, whenever you want to automate third application,
we have to configure the third application.
No, configuration over. Configuration over. See, first you configure all three applications if required. Then whenever you want to automate third application, what will happen? What we have to do?
First and second we have to disable.
Not disable here, no disable concept. Just run third application configuration script. Then automatically it overwrites. No disable concept here.
Okay, sir.
Whenever you want to automate second application, just run second application configuration script. Then it will overwrite. you can create and execute tests on second application. Suppose after some time, if you want to use first application, run that first application configuration script. Okay, na?
Yes, sir.
Like this, you can maintain different configurations. Just a minute. Understand the concept, Kanti? Any confusion?
No, sir. Understood.
Just a minute. See. Tools, object identification, select environment, standard Windows, suppose test object class. Here observe left side bottom, reset option is there. This is come back to default configuration. Here 3 options are there. If you select reset test object, what will happen? It resets selected test object class only in that selected environment. Next, if you select second option, reset environment, then it resets selected environment. Here selected environment is standard Windows. Next, reset all option is there. Guess, Sujata, if you select reset all, what will happen?
It will reset the test object as well as the environment.
Reset test object means selected test object class under selected environment. Reset environment means resets selected environment. Reset all means resets all loaded environments. See, in this scenario, 4 environments loaded. Got the point?
Yes, sir.
Suppose yes, I want to reset only web environment. Select web, reset environment. Yes. Next, I want to reset only button class in this standard Windows. Here observe native class text to height width. Reset test object. Yes. Next, select the button. Default na. This is default. We can come back to default configuration. Next, suppose first I configured my first application settings. Then here generate script is there. Bottom left to right second option. Generate script is there na?
Yes, sir.
You generate the script. It is predefined AOM script. Suppose app1. Save. Next, come back to default configuration. Reset environment. Next, configure according to second application. Generate script. app2. Next, come back to come back to default configuration. Reset environment. Next, configure according to third application. Generate script. app3. Okay. See, whenever you want to use first application, generate first application script. This is predefined AOM script. Executable file, predefined AOM script. Whenever you want to run tests on third application, use third application script. Okay na? Any confusion, Sujata?
No, sir.
See, this is about maintain different configurations for same environment. Okay. We will meet tomorrow, same time. Thank you.